Hello there, my name is Alan, and this is part of my tutorial series on the development of C++. Today's lesson is on what's called code relocation, that is, relocating code, not from your kitchen to your garage, but from one location in memory to another. Or that might be relocating code during the process of compiling, and it may be something that happens dynamically. That is, while a program is running, it might relocate some of its code from one place to another, and that's one of the things I'd like to look at. Now the second bit, addressing the data that follows, is something that I'm going to have to explain later on. But in a nutshell, sometimes code and data belong together, and we have an example of it in our code to do with that string len and string end len and all that stuff. And specifically, I'm talking about that terminating character. That little terminating character is actually located at a specific address relative to the string len function, as it turns out. So that piece of data actually moves around. If you moved that code, that piece of data would move along with it. Okay, now why am I talking about this instead of jumping right into the next bit on the parsing? And the reason for that is quite simple. I couldn't jump right in to the next bit on the parsing because I forgot to do something before finishing up the last bit. And I'll show you what I forgot first. Here's what I forgot. And I'll call this broken. What is it called? Well, it wasn't broken. Now, I had already taken the code that you saw before and moved it into this file. You'll notice that this is the same code, and it's been slightly modified. I started modifying it. First thing I wanted to do was save off that terminating character so I could restore it after the parsing is finished. Because, people maybe expect this to be 0 normally. So if I've changed it to a space, I should change it back to whatever it was before. That's one bit. The other bit is there's a block of data that I forgot to add here, and that is these pointers that get passed into main. The this should be v, argv pointers. That's each element of this is 2 bytes long and contains a pointer to one of the strings that goes in this storage area. And I should be filling these in as we go along through the loop. In fact, it's quite easy to figure out where that can be done right here. It could be done after the big table's been filled in, but here I have it right now, and I know where I am in my count, for each string. So why not just write it out now? Now is the natural spot. So I just, even though I had started on the next bit and gotten rid of all this code, I wanted to make those modifications to the current project. Now, instead of starting all over from scratch, I figured I could just make the modifications to this bit and then link it in with the existing code. That's what I'd hope for. Now the other thing is, another thing is the size of this table. Actually, there are several things you're going to notice that have come up between me saving this off and working with the second part of the parse. How big should this table be? How many possible pointers can we put on the in this list? And that's something that you can work out by logic, but you could also just try it for fun. Here's our program, if you recall. Alright, we type in arguments, fills in the table. So now, if I want to maximize the number of pointers that go in this table, all I need to do is put as many possible spaces as I can. So just go on and on and on, and the more A's I add, the more pointers there are. But I still have that batch file, and I think it's ready to go, in fact. No, that's not the maximum. Frog name. That seems like more than, well, that might be the maximum. Yeah, actually that is the maximum, I think. Yeah, so 10, 20, 30, 40, 50, 60, well, let's say no more than 70 bytes total for that table. That's the, maybe I can do more again if I rename the program. Change this to M, see how many we can fit. See if we can do that. No. No. Cannot find it. Oh, we did that. Well, now we're on to the next line, so it does take another one. Can I add one more? Oh, we can do another one. So we're up to 70, the table anyway. But definitely I'm not going to be able to get to the end of this line. So however many lines that is. 1, 2, 3, 4, 5, 6, 8. 8 lines is enough. Now, the other thing I thought that I'm printing these two things out, and I want to also update the count. So I went into this file, and I'll show you some of the things that have changed. For one thing, this, you may not have noticed, but in the other file, Here it's 11E and 120, and here it's 170. So the position of these buffers has changed. Also the turn car, it's always one less than Stirland, and here it's 111 for some reason. Oh, okay. I always put 111 when I don't know the address. This thing depends on stringlen, and I don't know exactly where stringlen is. Here it's just some weirdo number. I've said imports here somehow, but it's star there. Okay, so a lot of the stuff is shifted around, but that doesn't matter. All I wanted to do now was just copy this code, and I know it's duplication, but I just wanted to print out the little argc as well. I should have turned it into a function. I was just going quickly. I figured I'd be deleting this right away. Okay. Now, in this scenario, the build process is that. It's going to maintain the code, the binary code that I already had, and add this new code to it so that I don't have to go and add the other stuff back. It's not making a new OBJ file. It's a what we call like an incremental compile. Okay, so everything should be the same, and there's some extra code I added. And I'm just going to run my program. I could use that G thing. 3m.com. iprog abc. And now look what happened. This is supposed to have printed out 2 bytes. Instead, it's printed all this other junk. And it didn't take me long to find out that there was a stupid error in the debug dumping code that I have. And in fact, there's 2 errors. One is this. I had something backwards, sign reversal, and it always printed out this extra little dot, and I wanted to fix that anyway. So I didn't mind going to have a look and fix it. Okay, all right. So I go and fix it. I go and I start fixing that. Now, okay. Now, hang on a sec. Okay, yeah. So the thing I noticed was this. I have the fixed version. I don't need to show you how I fixed the bug. That's irrelevant. Here's the code, the debug dump code. Okay. Now, I could make a test program right here if I like. I will. Okay, now I'm just going to leave this as it is. I'm going to make a new file. I'm going to put a little bit of code in it. I'm going to use the debug dump program utility. It doesn't have to be called this, but it's consistent. Don't know where it'll be. We'll say 200 for now. The way that thing works is it takes a integer size, let's say 2 or 3, and then a segment value. All our segments are the same, and then an offset value. I'll say 0 for the PSP because I know what should be there. Should be a CD 20, and then whatever next. And push that. Call a function. Add 6 back to the stack and return. And that's a program right there. It should compile. This is making a new thing. Now, it's a little bit small, so maybe it's only 16 bytes. And I want to include this object file in it. So, if I, well, I wanted to include this object file, right? And then I thought, well, how am I going to get this? How am I going to get this in here? Well, one way I could do it would be to, just open up this one, and then save it as this one, and then use my regular linking. So I could do that. Why don't we do that? So delete test obj. And then I'll debug the thing I want. I'll rename this to test.obj. And I want to make it a bit bigger. This is the actual size, 182. So I'm going to make this bigger. How big do I want it? Let's say 500. And now I want to move this code away from where it is now. See, it's at 100. And I'm going to put something there. I don't have to, but I'm going to. So it's nice and big now. It's going to be 500. So I'll just move the code from 100 to, in fact, 2A2 to be precise. And I'll move that up to 400, let's say. And let's make sure that it's there. Certainly looks the same. Now we don't have the CCs, but okay, what I could do is first fill it up with CCs. Now let's see now. I'm certainly safe to fill from 300 over 300 to 500. How about that? And then I'll do the move again. 2A2 to 400. There we go. Now we got all our C's. And that's the correct code. Okay, and it should stop on a return and then CC, so it's perfect. Exactly the right thing. Now, I write it out. 500 doesn't mean this 500. This is always, this number is always 100 less than what this one would indicate. 500 includes all this stuff. In fact, it goes up to 600. So, what do we got here? Now we got our test OBJ, and now if I edit my file, if I don't use the builder, if I just use the linker, when I call, well, I put it at 400. Presumably, this call now is going to call the function. Well, first I'm going to show you why it doesn't. Okay. See how it's maintaining the size? Okay. That's the test, all right. Now, it turns out that this function is not actually the debug.dump function, but that function is slightly further on in this object file. But we did land on nearly the right spot. Now, I'll show you where it actually is, because I just know by looking. It allocates 100 bytes from the stack, and here it is. See, it subtracts 100 bytes, hex bytes. So that is actually DOS debug dump. So we could change it to say 46A, 469 in our program. So change that to 469, and now it should work. Okay. And there, you see it worked. It printed out the 3 bytes, CD20, and F. And you'll notice, by the way, that aside from the fact that we had to go and search for known locations of the function, that code just worked. Now, that particular piece of code, now fixed, is in fact just designed to work like this. That is, it's designed in such a way that it doesn't matter where it is in memory, it's always going to work. If I put it somewhere else in memory, okay, now it's at 400 now. Here it is. Okay, now I'm going to first increase the size of our program again. Let's make it 2,000 big. Okay, and I'm going to fill up from, I don't know, that's at 400. 600 should be okay. What's the end? The end is 5A1. So how about go from 5AA, that's beyond the thing, and that's said 2,000, I said? Well, it's fill 5AA. $2,000, yeah. Oh, 2,000 actually goes beyond that. So let me just build it more. It's going to be 20 at that. Alright. Let's check it out quickly. Now, I'm going to move that code. First, I just want to move it down 2 bytes. Okay. Move 400 to 600 is more than the length. 402. Okay, so now it looks weird, but in 400, I just put a small jump, which is only 2 bytes long. So now that's lined everything up properly. And of course, the location of the function is shifted down to, here it is. So now it's 46b, okay? So that's what I want at 400. Okay, let's make sure it goes to the right place. That's it. Okay, so now we want to write this out before moving anything. And now I can just say 400 here. Yes. Okay. Yes. Okay. So you see that extra jump now has changed things. See now wherever I copy the code, it's 2 bytes bigger. That's no problem. I can use the header address as the address where the function is, because it just jumps some relative distance. And so now, with this little addition in the front, I have a general utility that I can put in anywhere I want. It's going to work. It doesn't require any other functions. It's self-contained. It has its own printing and everything. And I built it that way on purpose for debugging, because it was a case where I couldn't use the actual debugger. Now, that's true of this function, that it can be relocated. It can be put anywhere and it'll work exactly as it has before. In fact, now with this jump here, I could relocate it and just change where this jumps to. But I won't do that. So yeah, so let me just move it 400. It's less than 200. Less than 200 big. I'm going to put it at I don't know, 1250. Okay. Now it's automatically updated this jump instruction. So now it's at 1250. Still works. You see? That's what I'm talking about by relocatable. Not all functions have that property. And in particular, those ones to do with the strings and that terminating character. It's because of that terminating character that those functions are not relocatable. And I'm going to show you in the next video why that is and how to fix that.